Hello, I am recording here the talk presented at Clojure South Conference on this 2025 year. The title is Decomplecting Clojure.spec from Validation to Self-Discoverable Semantic Services. So let's start. Decomplecting is about separating or splitting different parts that were combined or mixed. And following the talk title, it's a promising that there is something called self-discoverable semantic services inside the specs. But what's that? And I remembered this Woody Allen film where he was trying to convince her about kissing at the beginning of their first date because they will enjoy better the dinner. And to me, she was like, what? What? Very similar to the one that I think you can have with self-discoverable semantic services. What? So to relax and enjoy more the talk, let's crash into that hidden Clojure code that lives into Clojure.spec, and it is about self-discoverable semantic services. Are you ready? Let's try. So this is the code. Sorry about disappointing you about not having something apparently better or more spectacular. But as far as it's the only thing we have now, let me establish some relation between this humble code and the amazing Clojure.spec library. So behind the curtains, spec has a registry. That's the mutable atom. And there, all defined specs are stored using the qualified keyword as key and the spec implementation as value. As you can see, I am using this in this talk. I am using this talk details as example. So keys and values are slightly different. So far, so simple. Nothing more Clojure style, nothing more easy to understand. Of course, we can fetch values using the keys, and we can add more values to the registry atom at any time, at any place. We can ask for the keys, and so far, so on. For example, let's try to fetch the talk headlines. Can I ask you a question? How much semantic meaning is already embedded in these namespace sentences? They look like normal English sentences, but condensed, structured, packaged. Note that the prefix SDSS is shorthand for self-discoverable semantic service. And if I sort this data, these meanings naturally group into a structure that lets us understand the talk's headlines in a different way. I don't know about you, but I am discovering more about this talk just by doing this. Just by sorting, I can see 5 groups: Clojure, namespace, keywords, semantic, spec, and talk. But since spec is part of Clojure, I am going to prefix this section with Clojure. So from here to here, and let's repl again. And now let's sort again. So we had 5 groups and now we have 4. Clojure, talk, namespace, keywords, and semantic. I am trying to improve still more. At that point, I could also notice how namespace keywords relate to file and directory structures. Let's explore that connection. Good. Let's try to sort again. Great. Now I have three main groups. And now I am just playing with meaning and colors. In my opinion, this is so powerful, working purely with meaning, without writing actual code implementation. No files, no directories, just semantics. I am doing manual data visualization here, and I find it really revealing for understanding. Okay, we already saw the hidden code on that spec library, and now let's move ahead on the next outline, my self-presentation. My name is Juan Antonio Ruz Velasco. I am Spanish and work there too. I work at Jorva company as principal engineer. I'll expand a bit details about the company. Jorva is a small, very familiar company with great ideas. It has a strong ethical direction, protects digital identity, and the team is skilled and diverse. At Jorva, we develop an app also called Jorva.app. That is a digital footprint management platform that helps people see and act on their full online presence. Jorva identifies online accounts, mailing lists, subscriptions, and risky data sharing patterns. Users get actionable tools to reduce digital clutter, unsubscribe, delete accounts, save on unused services, and monitor breaches, all in one place. And here's my GitHub URL in this map. Notice something, again a self-described meaningful keyword values map. So that's all about my presentation, and let's jump to the next talk outline. Clojure.spec semantic communication how-to. Spec is awesome, but notice how conceptual it is and needs to be. Do you really understand the meaning of these paragraphs? I am highlighting a couple of sentences, but expressivity greater than proof. There is so much more we want to communicate and verify about our system. Do we actually want this communication and verification about our system? And this sentence about some static notion. Should we even care about static notions? So there are also another interesting parts on these paragraphs, and this is about type system. A spec is not a type system, period. And this goes beyond structural representational types. So these sentences are so profound that I am writing them down as big talk sentences, core ideas worth remembering. I am impressed by how expressivity and communication shape specs design. Now let's explore specs prior art to understand where the ideas came from. So Almost nothing about the spec is novel. Wow, because it appears really cool. Defining spec, isn't this line beautifully readable? But was it always this clear? And wait, isn't Clojure about functional programming, pure functions, immutability? Then isn't this odd? You give s/forward def something and it returns exactly what you gave it. By functional principle, that means either the function does nothing useful or something is changing, mutating in the background. But forget about the functional programming for a moment. Just look at the data-oriented style, the composition. Could it be simple, more readable? I don't think so. Turns out this isn't as novel as I expected. So what's spec actually doing here? Nothing new, and two foundations mentioned. Notably, nothing less than RDF itself. Clojure spec is looking for representing information in the web. Not only information, but semantic information. Nothing less, nothing more. And if you are skeptical, watch Luc van der Hart's talk. He puts it well. By integrating structured RDF data into prompts, models can bridge the gap between precise structured knowledge and natural language processing, enhancing both utility and reasoning capabilities. I am leaving here these headlines about the semantic part of RDF. Data has meaning beyond just strings. Machines can reason about relationship. Different data sets can be meaningfully combined. So again, I am so impressed with this semantic influence on the spec that I'll add in my summary talk sentences. Then let's keep digging into RDF and semantics. But now let's dig into the fancy and cool keyword namespaced keywords thing. I don't know if I should have used here instead of loves to say is obsessed with. This excerpt is from Rich Hickey Clojure spec talk around when spec was launched. I've marked ideas that suggest Rich is advocating for something specific. Clojure supports namespace names. I think we are underutilizing them. Make a web service example of whatever. Take the bars as a parameter and return whatever you want. Not the bar system is the dumping ground for all knowledge. Is it just me, or does Rich sound frustrated, even a bit angry? So why is he frustrated? Why do people keep trying to put all knowledge into the bar system? What's wrong with that approach? What other options exist? And most importantly, why does Clojure specs design perhaps not coincidentally, follow the direction Rich proposed here. And before going deeper into these questions, did you realize about this sentence? A database anywhere about anything. Wait, databases are supposed to be specific, focused on particular domains, not anything. So, what's Rich saying? I am including here a very simplified example of the first slide about hidden Clojure code, hidden discoverable semantic services code, but really simplified. But isn't this service a database about anything? But what do we mean about anything? So I am taking advantage of my notebook here, and I am including a couple of sentences more about this namespace power. And also important to note not the bar system is the dumping ground for all knowledge. Anyway, let's move to the next headline of this talk. Spec dev versus core dev. Didn't you realize about this similarity? One is a special form, the other a macro. One takes a symbol, the other takes a qualified keyword. But a spec doesn't allow to add docs. But you can't add metadata to spec definitions either. So this seems very contradictory. The spec API for adding entries to this RDF semantic registry actually restricts how much data we can attach compared to regular Clojure definitions. No meta, no docs. So what happened to so much more we want to communicate and verify about our systems, and the value to be assigned optional in core dev, required in spec dev. Before we dig deeper into specs design and usage, notice the crucial difference: the data type chosen for semantic identity, namespace keywords versus symbols. Why? It's time for Clojure semantic identities. And let's start by semantic meaning before getting deeper into Clojure identity specifics. We saw in the RDF slide that data has meaning beyond just strings. But what does meaning actually mean? The term semantic came from ancient Greek semantikos, significant or meaningful, root in semainon, to signify. Let's explore semantics across two different contexts, philosophy and computing. So, computing seems so clear that then let's go first on philosophy take. How symbol signs relate to what they represent. So this is casually the docs of core dev. Clojure dev special form seems surprisingly philosophical. It's about how symbols relate to what they represent, and those symbols can be namespaced. So Clojure core dev shows us how this works. In software, we call this name resolution, what a symbol refers to when evaluating code. What a symbol refers to when evaluating code. Symbols act as identities through bars. Remember something about bars? Not the bar system is the dumping ground for all knowledge. So dev and symbol aren't sweet for all knowledge. What other identity mechanisms does Clojure offer? So in Clojure there are 12 data structure types, and 2 of them are about identity, symbols and keywords. So symbols are identifiers that are normally used to refer to something else. We read the symbol as data, the text data, but when it is eval, it refers to a different value. Semantically, symbols are code identifiers. During evaluation, they are replaced by the value they identify in the current context. But keywords, identifiers on evaluation, so keywords evaluate to themselves. Keywords are pure data with identity value. At eval time, they behave like literal strings, but are faster for comparisons. So presenting here a table form for clarity. Since clojure.spec requires qualified keywords for semantic RDF purposes, let's examine keywords more closely. Keywords are straightforward, simple. We usually use them on maps and for dispatching. The keywords characteristics, they are data structures, they are literal values, they can behave as a function dispatcher, but they can't be defined. If you take a look to these Clojure data structure types, meaning or semantic is supported only by the namespace option for symbols and keywords. There are no more data structures that can be namespaced. But if a namespace keyword is a semantic value, then we have semantic values as pure dispatchers. In a specific context, for example, a simple map, it's a semantic dispatch. Semantic identifiers that reference concepts rather than mere strings, enabling self-documenting data structures that carry semantic meaning. Instead of assigned identity, for example, database IDs or system UUIDs, auto-generated. Keywords, namespace keywords have inherent identity. Things identify themselves by their semantic nature. By the way, they existed before clojure specs. So here some consequences of these namespace keywords. They have semantic stability. They work for information, for labeling data in information flows, and they work as universal property names. So they fit the purpose of open systems. So let's show a very tiny example of how applying these ideas to a simple documentation semantic service as an example. So we'll need 4 parts: a registry that, as I showed on the beginning, is just a Clojure atom, a documentation service where we place the logic to register or define docs documentation, and then we need to add the docs definition on any namespace, so they will be evaluated at any moment. Then we need something for testing the result. So these are the 4 parts. Let's start with the registry, the simple atom. We ensure that we only load it once. The documentation service is just doing the same as Clojure spec. So it receives a keyword, a namespace keyword, and a value, and we only need to add to the registry. So this is the simple version, but as far as we are adding something to this registry, we can validate the data that we are going to include in the registry. In this case, we want to assert that this documentation map that will be passing to this def function will contain a summary property, a summary string property. Also, I am including a spec function to read the summary based on the related keyword. So here, on any namespace, we can define our docs. So using a namespace keyword and defining the doc, the services documentation // summary content. That's the purpose of this definition. I am defining 3 docs. And now I am testing. So I just ask to this service documentation for the summary docs for a specific keyword, and this is the result. So everything seems to work like expected, and at any moment I can fetch all the keys of the registry. So we could get all the documentation at any moment of any keyword. So yeah, so that's the end of this example. Let's keep talking about RDF, identity, and namespace keywords. So let's explore RDF and specs via namespace keywords. If specs relate to RDF, where's the RDF? Where are the triples? When does RDF begin? Where does it end? So this is the start of clojure.spec and RDF relation. And here is the RDF registry UN with. Why I have called this a RDF registry if it doesn't contain any RDF triple? Well, clojure.spec has a global registry, this Clojure atom of Clojure map, that basically tracks all specs we define or as I like to use, register. So if we keep adding specs to the registry is updated. I don't know you, but I don't see yet the RDF triples. What do you think of this translation? RDF triples have three parts: subject, predicate, object. Subject, the resource being described. Predicate, the property of or relationship. And object, the value or another resource. But notice the limitation. This system, this RDF system that I am trying to translate here from the spec registry to these RDF triples, this system can only be queried by one subject. This system can only be queried by subject. There are no predicate relation beyond has spec. So for a physical analogy, imagine a router.clg file containing all endpoint IDs and handlers. The registry is a single type aggregator. It's only about handlers in the router. The same is happening here. All the triples share the predicate, so all are specs. So yes, specs are RDF compliant via the namespace registry map. Living in a RDF triple is the start of semantic relation. But where is the actual RDF code? Can you see the code in this slide? It's okay. There is no RDF code related in a spec library. But instead of showing an empty blank slide, I am going to show this thing. Because all RDF related logic lives on Clojure core specifically, and specifically is about namespace keywords. Adding a last sentence to my notebook and jumping to the next outline. Here I am presenting quickly another example a bit more interesting. It's about something like integrand or component libraries, about defining system components. We'll need here 5 parts. The component service to register or define components and initializing with their system dependencies. We'll need any namespace to register this component. We will need a registry as the example before, and we'll also need a system service to have the logic to topo sort components to start the system from bottom to up. And the last part is just an entry point to call the logic for start the system. So here the component service, the place where we'll be defining components. And as always, we need a def function like clojure.spec that same as spec, it receives two values. One is the namespace keyword, the second is a value about the data that will be passing here is it needs to contain something called identity, also needs to contain dependencies as a collection of keywords, also needs to have a init handler function and a optional halt handler function. So is like any other component library. The option that we need, the properties that the component needs to be initialized. Okay, at the end of the file, I am including the logic for initializing. So that is only about calling init handler with the related dependencies. This is the example of how define components. In this case, there are two components. One is called clojure.spec that doesn't receive any dependency, doesn't need any dependency, and this is the init handler. And the other component is the something that we are calling code.java endpoint that has a dependency on this DB component, and the init handler will use this DB for initializing. So it's the simple code to show the relation between the two components. And then the registry, that it has the normal registry that we saw before, and in this case I am also maintaining a system atom for having there the components that the component initialized. In this services system, there is some logic about initializing the system using this topo sort logic. So this is just about Clojure tools namespace dependency, and it's just to read all the components, sort them, and then initializing from bottom to top. So this is not related with these semantic services, except on the search by key function that we are using to read all the components that are in the registry. So it's just give me all the components that live in the registry, the same that we could ask clojure.spec to give all the specs from the spec registry. And this is the initialization, the system init call and the result. So all the components were properly initialized and injected in order. So that's the second example. Let's jump into the problem of specs. Clojure.spec is not a type system. So I am not writing a user type when I define this user. this code really goes beyond structural representational types. That these are my open questions here, and they remember me this book, Naming Nature, from Carol Kaesuk-Jung. It's a very interesting book. It's a book about biology and the problem of naming nature. And naming is a software problem also. So let me digress to make this more interesting and connect some ideas. A few months ago, I randomly ended up reading this biology book. Not my topic, I was terrible at biology, but I wanted to understand the naming problem in software. I thought examining Zoology's approach to types might help. It was far more relevant than I expected, a perfect mirror of developers' problems. At some point in zoology history, while trying to name and classify nature, cladists appeared claiming to kill fishes as a species, category, type. The reason there are fish, a lungfish is both aquatic and terrestrial, that breathe oxygen, fish that live outside the water. So what's the point of a category that fails to group what it's supposed to group? If you watch Rich Hickey's talk, you immediately see how these biology ideas mirror the problem he describes with spec as types on this talk. Categories are observation, not rules. These fields often appear together, not these fields must appear together. One schema, multiple contexts. The same schema serves different purposes through context-specific selections, not through schema proliferation. And evolution is natural. New patterns don't break old ones, they just add new ways of seeing. And context determines structure, not the other way around. So, maybe not. The real semantic spec RDF registry mistake. Let's take a look to the RDF registry again. Let's compare these two services approach. This is the registry that my semantic service ends with. This is the registry clojure.spec ends with. Can you spot the difference? We can register more services, but can you do anything more with a specs registry that override last, if any, spec? No, because spec is one dimension. One dimension versus your semantic services 2 dimensions. That's fully related with RDF. And there is so much data we want to communicate. Let's remember RDF spec triples. A spec is 1 dimension. All registered specs has same one and only one predicate. Let's compare with Jorba services. Jorba services is 2 dimensions registry value. two qualified keywords to get one value, and this is 1 versus 2 dimensions design is the part about maybe not. Now RDF has semantic capabilities to make relations. Interesting. But why is so important this one-to-one or one-to-n dimension in endless types spec problem? In one-to-one, we are semantically trying to specify an identity, same as philosopher Plato. Ideas first, then things are grown copies of ideas, but data doesn't keep stable for always. We need to embrace the semantic web vision, where properties are primary and structures emerge from usage. Reading now while we see the RDF relations. Categories are observation, not rules. These fields often appear together. Not this field must appear together. Multiple organizational schemes coexist peacefully. Evolution is natural. Context determines structure. The one-to-n endless type problem. We start defining a user, but then the request for the user, and then the payload for the post for the endpoint post request user, and so on so far. But there is also the naming problem. Why there are two ideas in this response payload. So one is the user and the other is the payload. Do we need to prefix user or do we need to prefix endpoint? Which is the correct name for this same combination of ideas? So there is no correct name. In this Jorva approach, we use two separate semantic IDs. So we don't need to get the combined identifier for something that doesn't change ever. We use the combination of two semantic IDs for defining the structure of that combination. And this is the last chapter. It's about the paradox. So, do files and dirs really exist? Well, I am showing here a normal path and a namespace keyword. So, file and dirs versus namespace keyword metaphors to solve semantic identity. So traditionally in file and dir metaphor, the path is the ID and type of the value stored on some machine location to be processed. But files and folders are just purely metadata. They are indexes, not containers. They make sense semantically for the end user metaphor of putting things into places. But Clojure namespace keywords doesn't need files and or folders. They are just pure semantic reference that doesn't eval to vars, but to the same keyword namespace value. Do you remember the tall outlines? They didn't need any file or folder to be used. So keywords doesn't need files, and a spec can be defined anywhere. That brings a unexpected problem: how to find my specs and or keywords. So, do you remember about keyword as data identifier? Then we can use a static analyzer to find them. We can write easily a Clojure condo script to get all namespace keywords that are part of a semantic service. And also we can query all the semantic definition that a semantic service has already related. So that's all. If you have any question, you can use Slack for sharing them. I'll try to answer as far as possible. Thank you.